I want to show you a kind of section you can use when nothing else seems to work. It's kind of the miscellaneous category of the section world, and it's called a broken out section. It's useful when you don't need to do an entire full section, you don't need to do an entire half section, you just need to show some little place on your object. I like to think of it as taking a bite out of the part, which this illustration kind of illustrates here. So what you do is you draw an irregular line using the object layer, so it's a thick line, and you just, I use a polyline, I just go zigzag, zigzag. You want to make it clear that that break line is not part of the object. It's clearly irregular, so nobody can think, oh, is that some edge? So it just looks like you took a bite out of the thing. And now the part that you're trying to dimension is visible, and you can dimension that part. Here's an example, kind of similar, where they're sectioning through that boss that's sticking up. Now, you probably remember that ASME says no hidden lines in section views. And we kind of emphasize that, we emphasize that as we go along. And then you come to this illustration in the most current ASME standard that relates to sections, and here is their example with hidden lines in it. And if you look around at other examples, say from other textbooks, you find something similar. Broken out sections, but the rest of the view often has hidden lines in it. So what do we make of this? ASME does not give us words to talk about what it is they think they're doing. These are the only words that ASME gives us. When it's necessary to show only a portion of the object in section, the section area is limited by a break line, and the section is called a broken out section. No cutting plane is indicated. That's all they say. So, all I can think is that they're treating this as a regular orthographic view that just happens to have a bite taken out of part of it. So, this is my interpretation, but I think they are saying this isn't really acting like a section view, therefore it's okay to keep your hidden lines in there. And you can do that with the part that you'll be drawing. We'll go look at this in CAD in just a minute. So here's the part that you'll be drawing. It's a nylon handle for some kind of tool. I don't know what. And mostly we want to show the outside, but we do want to do a broken out section so that we can show these various grooves in here as visible so that we can dimension them. And you can see there's a lot going on here. There are a lot of dimensions. So what we're going to do, and I'll show you in a minute, is we're going to do one or two circular views, and then this side view with a bite taken out of it. And then you can place dimensions in 2 or 3 different views, so you can make it a little bit cleaner looking if you want to. Now, this is a small part. Look at this. It's just a tiny bit more than 7/8 of an inch long. 7/8 would be 0.875, and this is 0.880. And it's just a little over 13/16 of an inch in diameter. 13/16 would be 0.8125. This is 820. So this is a small part, and you have to get a lot of dimensions on here. So I recommend that you scale it something like double size in your viewport, which we will go look at. For now, let's just remind ourselves that whatever your viewport scale is, your drawing scale factor is the reciprocal. So if your viewport scale were 2 to 1, your scale factor would be 1 to 2. And I try to show that in this table. I'm sorry there's so much text on here. So if your viewport scale, your plot scale, were 2 to 1, or 2 over 1, then your drawing scale factor would be 1 over 2, or 0.5. If you are doing that, if you're scaling your drawing 2 to 1, and your drawing scale factor is 1/2, then you put that drawing scale factor in places like your dimension style fit scale. So let's go look at that. I think we're done talking here. Let's see, are we? Yes, we're done. We're done talking, so let's stop now and we'll go look at a CAD drawing.